Welcome back. It's time to talk about full domains. Now, we've had full domains for a long time. If my memory doesn't fail me, full domains were created back in 6.1. I could be wrong, maybe 6.061. So let's talk about what full domains do. And prior to the break, I've mentioned that full domains make vSAN rack aware. One of the most important things to understand is the difference between an implicit full domain and an explicit full domain. Each host on its own is an implicit full domain. Now think about this. Imagine you have 6 ESXi servers in your cluster and you have 2 hosts per rack. The problem with our full domains is that our software doesn't know which hosts happen to be in each rack. So there's a good chance that when you create a VM, if the VM is a two-way mirror, potentially you could have 2 sub-mirrors on 2 hosts in the same rack. Now imagine if you lose that rack. At that point, you lose the majority of the votes. So with full domains, in that scenario with 6 hosts, you could easily create 3 explicit full domains, add 2 hosts in each full domain. So that way, if a sub-mirror goes in the first host in the first rack, the second host in that rack would never be used for the other sub-mirror and or the witness. So when you look at this page at the very top, here notice it says vSAN full domains can spread component redundancy across servers in separate computing racks. So once again, this feature is making vSAN rack aware. Notice it says vSAN requires a minimum of 3 full domains to support FTT1. Once again, you need to have either 3 implicit full domains, meaning 3 ESXi servers on their own, or you would need to have 3 groupings of hosts. But again, we're talking about 3 explicit full domains in that case. Now, if you think about it, if I have, for example, 6 hosts, but I put 5 in one full domain, technically there, I would not be able to create a VM and make it a two-way mirror. Because in that case, if I have 5 hosts in an explicit full domain, those would count as 1. And then the host outside of the full domain would count as another one. So I would only have altogether 2 full domains. So when you take a look, it doesn't make sense to create an explicit full domain with just 1 host, because remember, each host on its own is an implicit full domain. So when you take a look, here we talk about best practices. Now, if you look at the first bullet, it says provide enough full domains to satisfy the failures to tolerate the value that is configured in the storage policies. Once again, for example, for RAID 5, I would need 4 hosts. So in that case, I need either 4 implicit full domains or a combination of implicit and explicit full domains. But again, they need to total at least 4. Notice, ideally, you want to put the same number of hosts in each full domain. So if you think about my analogy, I mentioned 6 hosts and 3 racks. And I mentioned to put 2 hosts in each full domain. And again, ideally, you want all your servers to pretty much look the same, your racks to be the same. So that's something to consider. Now let's take a look at this particular scenario. Here we're talking about implicit full domains. So remember, in this case, I have 4 hosts. If you don't build explicit full domains, these are 4 implicit full domains. So in this case, I could very easily create a RAID 1 VM if the VM is a two-way mirror. For that matter, I could even use RAID 5 because again, I have 4 implicit full domains. In this case, I have a VM. The VM is a two-way mirror. 1 sub-mirror on the first host, the other sub-mirror on the other. That's what they mean by C1 and C2. We're talking about replica components. And then in this case, we have the witness on host 3. If I lose, let's say for argument's sake, host 1, I could take the copy of host 2 and rebuild the missing copy onto host 4. If I were to put 2 hosts in an explicit full domain, I could create a two-way mirror VM, but then if I lose a host, You got to consider what would happen in that particular scenario. So when you look at this illustration, here we have a system, or an environment, I should say, with 4 racks. And in this case, each rack has 4 hosts. So we're following best practices. Same number of hosts in each rack. So in this case, what we're doing is we are creating 4 explicit full domains. Each explicit full domain covers 4 servers in a rack. Now in this case, can I create a two-way mirror VM? Yes, because despite the fact that I have 16 servers, they count as 4. Remember, here we have 4 explicit full domains. Now, would I, in this case, be able to create an array 5 VM? Yes, because again, I have 4 explicit full domains. But despite the fact that a 3-way mirror VM requires a minimum of 5 hosts, I would not be able to create a 3-way mirror VM here, because again, I have 4 full domains, and I would need to have 5 full domains, either explicit or implicit. So in this case, I would not be able to create a 3-way mirror VM, a 4-way mirror VM, or for that matter, a RAID 6 VM. I'm going to do a demo in a few minutes, and in that demo, I will show you exactly what I mean, and I will show you how to create full domains, modify them, and eventually delete them. When you take a look, what follows is going to be lab 2. And when it comes to lab 2, notice the lab is called Analyzing the Impact of Storage Policy Changes. So remember, I'm going to do a series of demos first, and you're going to see what happens when I try to, for example, modify a policy that is in use. I'm going to show you what happens if you try to delete a policy that is in use. Remember, you cannot delete it. I'm going to show you that you cannot, for example, delete the default policy, but you could change it. And if you take a look, this is lab 2. And following lab 2, you have another lab. This one is lab 3. You can see this one is called Identifying Objects with Reduced Availability. So I want you to look at my demo, because in my demo, I'm going to create a network partition. And as I do that, you're going to have absent components. Also in my demo, maybe I will reboot a host. Once again, we're talking about absent components. And later on, I will show you a Python script that allows me to emulate injecting a permanent failure, if I want, onto a disk. That would be an example of degraded components. What follows that is lab number 4. And in lab number 4, you play with full domains. So make sure you pay attention to my demo. And then after that, you get to do 3 labs in a row. Thank you.